It's fine. Okay. 1. Number 1 is x plus 3 times x minus 5 times x plus 4. X plus 3 times x minus 5 times x plus 4. Number 3, I'm going to try to, if I skip one that you did, I'm going to try to like get all the ones in order and try to go through it all only once. So I'm going to, if I skip one that you did, let me know and I'll do it. Okay? So number 3 is x plus 5 times x plus 2 times x minus 4. Number 4, we did 4, right? Some of us did 4, yes. Okay. Number 4 is 4 times x plus 4 times x minus 2 times x plus 3. Number 6 is 2x plus 1 times x minus 3 times 3x plus 4. Number 7, okay, is x plus 7 times x minus 1 times x plus 3 squared. Excuse me. And then 9 is somewhere. Is 5x cubed plus 17x squared plus 74x plus 295 plus 1,192 over x minus 4. Number 10 is x to the 5th minus 4x to the 4th plus 9x cubed minus 19x squared plus 41x minus 83 plus 190 over x plus 2. Number 12 is 2x cubed minus x squared minus 41x minus 20. Number 13 is 3x to the 5th plus 3x cubed minus 6x squared minus 2x plus 4 minus 2 over 2x minus 1. Number 15 is x plus 4. Number 16 is, excuse me, 2x squared minus 8x plus 9 plus 5x plus 24 over 2x squared plus x minus 12. Number 18 is 4x squared minus x minus 3 minus x plus 10 over 3x cubed plus 2x squared minus x plus 6. You know what would have been smarter is if I just put the answers up on the board and then you could have found your things, but we've already started this way. We'll continue. Here we go. Number 19 is x cubed plus x squared plus 5x plus 4 plus 2 over x minus 2. Number 21 is 3x cubed plus 3x squared plus 47 plus 24 plus 48 plus x minus 4. Was there some question? Something? No. Okay. 22 is x to the 4th minus 2x cubed plus x squared plus 4x plus 1 plus 4 over x plus 2. 24 is 12x cubed minus 6x squared plus 6x minus 12. 25 is 15x to the 4th plus 12x cubed plus 9x squared plus 6x plus 20 plus 76 all over, and they did the factored version of the denominator. So they did 3 times 3x minus 2. That would be the most reduced version. You might have had 9x minus 6. 7 is 12x to the 5th plus 6x to the 4th minus 3x cubed minus 5. 28 is 8x to the 5th minus 12x cubed plus 6x squared minus 15. Excuse me. Did you do 29? I feel like I missed count somewhere. No? Okay. I'm flying blind. Here we go. All right, so let's see. What will be next? Next would be 30, yeah? 30. Did anybody not do 30? You. Okay. 540 meters. And 31 is 711.
I actually miscounted from here, so I did 32.
Okay, great. Not a problem. it's all bonkers right now anyway, because I know how to fix it for our next one. It's going to be not a problem. 11,165. 33 is 45,536.
I need
35 is negative 67,978. 36 is negative 686.
38.
38 is yes, no, and f of x equals x plus 2 times x cubed minus 4x squared minus x plus 3. And then 39 would be no, and also no.
Pass those, I didn't finish the problems. I had 41, 44, 47 left.
Okay.
I didn't know how to answer.
Okay. Where would we be at 40, 39 and then 42? No.
45 is what I did.
40, you skipped all the way to 45?
No, 42 to 45.
Oh, 42 and then 45. And then 47. Okay. 42 is 4x to the fourth minus x cubed plus 36. No, that's the problem. 42 is yes and no. And f of x equals 4x minus 1 times x cubed minus 9x minus 30. And 45 is yes and no. F of x equals 4x plus 3 times x to the fourth minus 3x cubed plus 12x squared minus 3x plus 21. And 47 is 5 seconds. Are there any that you did that I didn't give the answer for? Okay. Aiden, to facilitate your unless you are like, I don't actually need that, I'll go ahead and put like the answers up on the TV while I start taking questions.
I checked them at home.
You check, how did you check them at home? Oh, some of them are odds. A lot of them are odds. All of them are odds. Is that what you're saying?
Yeah, and the photo math.
Yeah. Assuming photo math doesn't break it.
Yeah, but they use the answers from the book, I think.
Okay.
Math they use in engineering dad. Also gets confused.
Right. Yeah, sometimes engineering dads can be like anti-helpful. Not because they don't want to help, but sometimes they're like, well, you really should probably take the derivative of the or the whatever else.
Usually, can we get that complicated?
Yeah, well, there you go. Okay, so what questions do we have on these? 4. Decidedly 4, apparently. Okay.
Let's do 4.
What is 4?
It's a long division problem.
Yes.
You didn't? Why not?
Because I didn't do 4.
Oh, right. Yeah, because we had, I,
Multiples of 3.
well, so what I said was every third, which is what Alexa did actually. But then when Bree was like asking about it, what I was listing was multiples of 3, and so that's why I read like twice the problems, because I messed it all up. What we will do today, probably if we do that, which I haven't looked at the next homework set yet. Today might be part in class and part video. Video's already done. Videos are already released. Videos are already there. I'm working towards getting back caught up because it's not going to be feasible to do all of the lecture in class for this class. There's just too much. I recorded like an hour and a half worth of video yesterday for one lesson. So, 4 videos, 1 lesson, and it was like almost an hour and a half worth of content. And so we'll be doing at least some of our lecture anyway, we'll see. It's going to be probably even more hybrid than normal, which is fine. Okay. Oh yeah, number 4 is kind of fun. Number 4 is interesting.
Did I do that?
I don't know. If you didn't, you should follow along. If you did, you might still want to follow along.
I did not.
4x cubed plus 20x squared minus 8x minus 96. And we're dividing it by x plus 3, is that right?
Yep.
Okay. All right. So we'll start by dividing it. X plus 3. So we're walking through the assumption with the remainder theorem, which if you watch the Algebra 2 video that I stuck up there, you would remember. If not, maybe you looked in the book. If not, you may have just been confused. Or you may have just YOLO'd, who knows? But what it says basically is if we get a remainder of 0, then this is a factor of that. Okay, so we're going to go and go. So this is 4x squared distributed back is 4x cubed plus 12x squared. We subtract. Which turns into 8x squared. And then bring down minus 8x. X into that gives us plus 8x. Distribute back over and we get 8x squared plus 24x. If I make a mistake, holler.
I got this problem wrong, so I wouldn't even know if you made a mistake.
Well, you can still catch my arithmetic mistakes. Everybody in here can do that to one extent or another. Minus 32x. X goes into 32. Let's see, bring down the minus 96. Is minus 32. Distribute that back over. That shouldn't be an x. That should be a 6. Negative 32x. Negative 96. And then we subtract. Which cancels everything and has a remainder of 0, which is what we expected because they told us that that was a factor. Right? So now we have x plus 3 times this mess, 4x squared plus 8x minus 32. And then we just need to factor this one. Oh, before we do that, what could we do first? We could take out a 4. We could have actually even done that from the beginning if we wanted to, and then we would have dealt with smaller numbers when we did the division. We just would have had to remember to shove it on at the end. So when you take it out is kind of up to you, but eventually you're going to have to take it out. We don't actually have to take it out right now. It just would be easier to take it out right now than the next step. So x squared plus 2x minus 8. And now she's easy to factor. I will also, just because it's worth doing in this problem, I'll show you in a second that you can actually wait till the very end to factor 4 out. 4 and 2 minus plus 3. So if you didn't take it out, we could have instead factored this into
2x plus 8 minus 4.
You said what now?
2x plus 8.
2x plus 8
minus 4.
and 2x minus 4. Now, what do you notice about both of these guys?
Take out 2 out of both of them, and then 2 times 2 is 4.
Yes, ma'am. All correct. So you may have got it right and just not quite finished it.
Yeah.
Yeah. All right. What else do we need, folks?
Why did I circle number 10? What did I do
Which
with
one?
10? Oh, no, why did I?
Oh, I actually had a question. How do you, so if you're looking to whether the thing on the top in long division is going to be positive or negative, you're matching it to the thing on the bottom?
Well, it's whatever it's divided. So like this goes into this, and positive divided by positive is a positive. Negative divided by a positive is a negative. Because you're dividing by this front thing. So it's whatever that would be. Like if it was negative and negative, right? Because we can do that in long division. We can't do that in synthetic, but like it could be negative x plus 3, and then this last one, then they would all flip.
But you're getting it to the thing you're dividing by, and then you just flip the sign. Like
Flip the sign?
The bottom one to subtract.
Yes, you flip both signs to do the subtract. That's what the subtraction is with the, yes.
We should do 16.
That'd be fine. I'd be happy to do 16. 16. It's one that looks scary, but it's really pretty easy, actually, if we remember. Ooh. 16. You cannot do using the synthetic division. Es imposible. But we can do it with long division. I'm going to go ahead and just put it in the house on the porch. Save myself some time and trouble. Ugh. So on the porch, we've got 2x squared. Something, I don't know. Plus x minus 12. And in the house, we've got a big old giant mess, but not really as scary as it looks. Not really, really. We've got 4x to the 4th minus 14x cubed minus 14x squared, and then plus 110x minus 84. So 2x squared goes into 4x to the 4th how many times? 2x squared times. And then we distribute back out. This times this is this one. X squared. 2x squared times x is 2x cubed. 2x squared times negative 12 is negative 24x squared. Then we subtract. So this one cancels, and then we've got negative 16x cubed, excuse me, plus 10x squared. And then 2x squared goes into negative 16x cubed how many times?
It goes in negative 8x.
8x times, and we distribute, negative 8x times 2x squared is negative 16x cubed. Oh, I didn't bring this down. And x, and then negative 8x times x is negative 8x squared. Negative 8x times negative 12 is positive 96x. Then we subtract. Bam, bam, thank you, ma'am. That cancels. 10 plus 18 is, no, 10 plus 8 is 18. 110x minus 96x is 24x. 2x squared goes into 18x squared how many times? 9x. I believe you. I actually totally believe you.
Is it just just 9 though? Yep. No x.
Oh yeah, it is. My bad. Thank you. And then distribute the 9 back out. 9 times 2x squared is 18x squared. And we remember to bring down what we forgot to bring down. And by we, I mean me. And then 9 times x is 9x. 9 times 12 is negative whatever, 108. Is that right?
Sure.
Correct.
Yep. And then we subtract. Cancels. 24 minus 9 is 15x. And then negative 84 plus 108 is 24. 2x squared does not go into 15x, so we are finished. We write down our answer as, or our remainder as plus 15x plus 24 over 2x squared plus x minus 12. You could potentially, I don't think it does, you could potentially try to factor those and it might reduce. What is the answer? Give something that looks like it's reduced?
No,
No.
it does that exact thing.
Yeah. So I don't know that the bottom factors. The top does because we pull a 3 out, but I don't think I don't know that the bottom factors. But it matches the key, so we're going to assume it doesn't.
Can we do 22?
We can do 22. Be quite happy to do 22. Let's do it. Let's do it. Synthetic division. Awesome.
All those pesky missing polynomials.
Pesky missing polynomial, words. 22, we're doing x to the 5th plus,
No, minus 3.
thank you, minus 3x. Oh, I might know what you did, maybe, possibly. Plus 6x squared, thank you,
Plus 9x.
plus 9x.
Plus 6.
And we're dividing by what, x plus something? 3? 2. Plus 2. Okay. Let me write this up there, and let's see if I'm right. There's 2 places I could see.
Why is it a negative?
Yeah, why?
Because you gotta do the.
Because when we're dividing, we've got to flip the sign here, because that takes care of the subtraction bit.
Well, that explains
When we're doing synthetic substitution, it just goes straight in as is.
Yeah, that explains most of it.
Awesome. Glad we found it. Bring down the 1, -2, -2, 4, 1, -2, 4, -8, 1, -2, 4. What are we supposed to do? What are we supposed to do? We're supposed to factor it all the way, or no, just divide it. So then all we're going to do is write the answer. So x to the 4th minus 2x cubed plus x squared plus 4x plus 1 plus 4 over x plus 2. Yeah. When you're doing synthetic division, you've got it divided by thing, you've got to flip the sign. Easy money. What else?
We can do, like 42.
Sure. You got it?
That would be helpful.
So I thought if more of them came out to not do the thing, then neither one of them worked, but. It's a little sad, I guess.
42 says the first one works, but not the second one. We will find. Well, we'll try it together.
Well, yeah, I just thought if one of them comes out to not work, then you can not do the rest of it.
Oh no. Not on problems like that. Because this one's just trying to see if you're kind of seeing into the future with a different type of problem is probably what you're remembering. Which means you're actually kind of seeing into the past, but whatevs. So we're gonna see f of x equals, excuse me, 4x to the 4th minus x cubed minus 36x squared minus 111x plus 30. And we're going to try it with 4x minus 1. We want to see whether that's a factor or if x minus 6 is a factor. Okay, so let's start with the first one and divide it by 1/4 synthetically.
So we have to make it a negative now? No, I'm wrong.
Which means this would be a 1, and this would be a negative 1/4, and this would be a negative 9.
Are you just doing the synthetic division in your head? Is that what you're doing here?
No. Let me write this all down, and then I'll remind you of what I'm doing.
I probably just missed the part of the video where I talked about this because I have no idea what's happening.
This would be a synthetic division thing, like this. You would have had to go back to you would have had to go back and watch the in-class lesson, or go back to the Algebra 2 video on synthetic division, which wasn't linked on there because we did it in class. So that would have been where you would have looked for it.
It was linked. I thought you did give us
I did the remainder and factor theorem, which uses synthetic division, but there's another lesson on synthetic division, which we did in class for us. Okay, so let me remind you what I did. Okay, so what's happening here is in order to do synthetic division, okay, in order to do synthetic division, this has to be 1. Okay, and so I've got to divide everything by 4.
It's plus 30, not plus 3. I was correct.
Where at, girl?
It's plus
Oh, I
30.
probably just left off a 0. Thank you.
You said it, right?
I'm sure I did, but then I wrote 3, which means this is not that. It's
15 halves.
yes, ma'am. I was getting there. Okay. All right. So yeah. So I divided everything by 4. So 4 divided by 4, 1 divided by negative 1 divided by 4, etc. So all of these coefficients divided by 4 is these. Make sense?
Yeah.
Good. Okay. Bring the 1 down. 1 times 1/4 is 1/4. That's a 0, which means that's a 0. Negative 9 plus 0 is negative 9. Negative 9 times a 4th is negative 9/4, which makes that negative 120/4, which would be negative 60/2, which would be 30. But I'm going to leave it. No, I'm not. Just kidding. LOL. JK. Negative 30, right? Is that what we get here? Somebody else agree with me? Somebody else there?
One second, I keep messing up signs.
I guess I could pull my calculator and sanity check myself. It is correct. Thank you. So this would be negative 15/2, which means this is 0. So that one does work. So yes. We already know from reading the key the next one's not going to work, but we'll do it anyways. Leave that one sitting there. So 6 into all that stuff. It's the factor is negative x minus 6. So we're dividing it. We flip it, right? We're using synthetic division. Negative 1, negative 36, 1 and 30. Bring down to 4. 24, 23, 120, no, 138, is that right? Somebody sanity check my 6 times 23.
138.
Great, thank you. Which means this is 102, which means that's 612. This is like clearly not going to work, right? So, it doesn't work. No. So then we're supposed to continue factoring it, right? If possible or something like that. What does it say? Use the binomials that are factors to write a factored form. What did it give us? Oh, okay. All right, that's fine. We could go further than what the key does, but we'll save that for the next lesson or two. All right, so that means, so the factored form of f of x, a factored form, not fully factored, but a factored form of this would be 4x minus 1 times x cubed minus 9x, right? Because there's not an x squared term. And then minus 30. And then, so this and yes and no are the answers. Good.
Did I have to do 47 just because it's a word problem?
Probably so. What was your question?
Answer. Get there.
Okay, so we just figured out that that was a factor of it, right? So we factored that out, and then what's remaining after we factored it out is this. Remember that these numbers in synthetic division are just coefficients. The first one, this first slot, is always 1 degree lower than this, what we were dividing into, right? So this is the 1x cubed. There's not an x squared term, so there's nothing here. And then negative 9x would be the next in decreasing order, and then negative 30 would be the next.
So that's just the adding the x's back in
Yes,
on the left.
yes,
The right one came from.
that, what we were dividing by. Because the fact that we got a 0 remainder tells us that it is a factor.
Okay, so it's the one that does work. So if
Yes.
if the x plus 6 works, then it would be x plus 6.
Mm-hmm.
4x. Okay.
Mm-hmm.
Okay.
Minus 6, but yes. Yes, yes, yes. 47, because it's a word problem. It's good enough for me. And then we'll get started on giving you an hour and a half worth of notes, so maybe you don't have to spend an hour and a half on Wednesday.
Oh,
It's also all review, I might add, from Algebra 2. Now, that doesn't mean you're going to remember any of it, but that might make it easier to absorb, possibly. 47, because it's a word problem. Patrick is cycling at an initial speed of v naught of 4 meters per second. Oh yeah, this is a good physics problem. I said that the other day. When he rides downhill, the bike accelerates at a rate A of 0.4 meters per second squared. The vertical distance from the top of the hill to the bottom of the hill is 25 meters. Use that formula to find out how long it will take Patrick to ride down the hill, where d of t is the distance traveled and t is given in seconds. Yep.
Can we just do physics instead of precalculus?
Well, that's what this is.
Oh, okay.
This is physics problem. All right, let's write all our puzzle pieces up here, and we'll see what we need. So initial speed, v naught. What am I writing? V naught of
Yeah, you're right.
4 meters per second. And what else do we need? Acceleration.
So A equals 0.4 meters per second squared.
Squared. And
The distance is 25 meters.
vertical distance. Is the d of t also the vertical distance? Is that what that variable is? D of t is the distance traveled. So the vertical distance, I'm going to call that the height. The height. We'll draw a picture in a second. My one, if you're in physics or eventually do take physics or whatever else,
Wouldn't that be displacement?
vertical displacement, yeah.
I'm not
Be if I was writing it in a physics problem, I would write it as delta y, but I'm going to do h here. And then it tells us that d of t equals v naught times t plus.
Is that the way to say initial? The v initial?
Mm-hmm. Yep. Yep.
I have not done physics in 2 years, so I don't remember what I'm looking at.
Luckily, we don't have to really know the physics, really, to do this problem. All right. T is time, obviously. D is the distance traveled, which is an important sentence in a way, because that's not this. Unless it is, and this book makes a mistake, which could be. Hey, we'll see. We'll learn. We'll find what the answer should be and see if it matches what they said. I think that sounds like lots of fun. What am I writing? Oh, this is in meters. That's what I was trying to remember. Yes. Okay. So this is at an incline, right? Right down. Yeah. Well. Yeah. Yes. Yes. Here. That tells us that, I don't know why I was doing nice lines and then all of a sudden abandoned my life choices. It says this is 25 meters, right? True enough. Maybe not. Well, because they didn't give us an angle, so I don't think this is what they mean. Because really this problem should have trig in it, but it doesn't have trig in it, and we don't have enough information for it to have. I think this is just this. I don't think the way it's worded. I don't like it, but I think that's what they meant. Because I would think that This would be the distance that, and we would need to find that first. But we don't have enough information to have that because we don't have either of the other sides or an angle to get this. So I think what they mean is this is d of t, which is dumb and wrong, and that annoys me a little, ever so slightly. But that's got to be what it means because there's no other possibility. Okay, so we start shoving stuff in here. 25 equals 4t, excuse me, plus 1/2 times 0.4 t squared.
I got the T on the left.
Did I? I did not forget it. It just is ugly. What left t? This is not d times t. This is the function notation, so it's d of t. So this whole thing is d of t. So start cleaning some stuff up a little. So let's move this over and multiply this, right? So we move this over, we subtract by 25 on both sides. And I'm going to also start writing this in descending order. So half of 0.4 is what?
0.2.
Okay, so 0.2 t squared plus 4t equals, no, just kidding, minus 25 equals 0. Now, just for grins and giggles, why is this problem in this lesson? This is just squared. This is like not even this lesson. This is like quadratic formula, whatever. Yeah, and I think it will factor. And what I would do if it were me is I would get rid of this decimal first. How would I get rid of that decimal first? No, that's still like get rid of that partial number entirely.
Divide everything by
Dividing is going the other way. Multiply by what?
0.2.
How about 10? Because that'll just bump this decimal over, right? So 2t squared plus 40t minus 250 equals 0. I can do something else to clean up before I try to factor.
Take out a 2.
Divide by 2 on everything, so it goes t squared plus 20t minus 125 equals 0. And then factor if you dare to something. What do you want to bet it's going to be? Negative 5 and something.
Negative 5 and then 25. Negative 5, positive 25.
So when we solve that, we end up with time equals 5 seconds or negative 25 seconds. But we don't like that. He's ugly. So the answer is 5 seconds. So we don't have negative time. Unless we're talking about some Einstein equations that seem to indicate time travel might be possible. But that's not here.
I watched a full video on that.
Did you really?
We had this playwriting competition for the theater group that I'm in, and I decided to write 3 pages of time travel nonsense because of that.
Nice. Sounds fun. Excuse me, sorry. My body decided to try to choke itself. Okay, any other absolutely pressing questions on this lesson? Or should we start 2-4? Start 2-4, here we go. It is the 2-4 is the video that I have made and is out on the internet, but you have not watched it yet. Well, I assume you have not watched it. I mean, you could have. You could have noticed.
Talking about the algebra 2 video.
Yeah, no, that's 2-3 stuff. The tail end. Nice. Okay.
On the homework, like when you post it, are you going to tell us the timestamp when we should start watching? Or?
Why would I do that? You are capable of scrubbing. If we're lucky, it'll be like you skip all of video 1 and do or whatever. But who knows? So we got 15 minutes, so we'll see what happens. So what we're going to do is we're going to jump into an example, and we're gonna learn it that way. Okay. So we're going to list all. We're trying to find the possible zeros, and what I said in these videos, and what you hear in the ones that you do watch, is all of 2-4 is ways, because what we were doing in 2-3 is they were like, here's a factor, divide this, then find the rest just by factoring like right? But you can do synthetic division forever. We can just try infinite number of numbers, and eventually we'll find all the factors and factor the stupid thing, right? Yeah, but in 2-4, we're getting ways to narrow down and be like, okay, well, it's not any of that, and it's not any of that, so let's try these ones, right? Okay, so what we're looking for is all the factors of P over all the factors of Q. P, factors of P, and factors of Q. P is the constant term. So in our long way of writing that would be the A naught, that one at the very end, right? That last guy. And then Q is, excuse me, the leading term, the leading coefficient. Okay? So that would be the very front term, that A sub n term, right? Okay. So if we're doing like example A, and I'm going to do in class, I'm going to do the straight up examples. In the videos, I did the guided practices. So this way you'll have kind of both walk through for whatever we get through today. So, all right. So we're going to list all the possible rational zeros of each function. So this gives you the fractional ones. It doesn't necessarily give you any irrational or any complex or whatever else. But there we go. So we're going to list all the possible rational zeros. Oh, that's stupid. No, we're not going to do that problem. Why did they make it that easy? How about this one? Okay, this is example 1B, because the first one is stupid. Way too easy to be useful. All the possible rational zeros of g of x equals x to the fourth plus 4x cubed minus 12x minus 9, right? So in this case, P is 9, right? Now, we can get to 9. Factors of 9 are, you can do what? We're finding all the factors of 9. Now, you can multiply either positive 3 or negative 3 and get a 9, right? Because I can do negative 3 times negative 3 and get a positive 9, or negative 3 times positive. So they're all of the P's and all of the Q's and all of the P over Q's are always going to be plus or minus. So it's plus or minus this, plus or minus that, plus or minus that, plus or minus that, okay? So in this case, what are the possible factors of 9? So I'm going to list all of these as plus or minus to get that in our head. Plus or minus 9, plus or minus 3, and plus or minus 1, right? Good. So those are all the factors of 9. Now this one is nice and easy. We like it when we have a leading term of 1. That makes our life a lot easier, right? The only factors of Q are plus or minus 1.
And Q is
The leading coefficient.
the one with the highest.
Yes. Yeah, the one in the front. Okay? So all of the possible rational zeros, all of the pot rats would be this divided by this divided by this, and this divided by this. So listing them in numerical order, just because. You don't have to, but just because. It would be plus or minus 1 divided by 1, plus or minus, you'll see why I'm saying all of these words in a second when it's not just one option here. Plus or minus 3 divided by 1, and plus or minus 9. So on this problem, Let's see, what does it say? Does it say to then determine which, if any, are zeros? Okay, so now we've got to see if it's a zero, right? So how do we determine if these are zeros?
We stick it in the calculator, look at the table.
So yeah, eventually, but we are going to have to prove it, and if you want to jump ahead a video or two, that's not a problem in this lesson. But we just got to start trying stuff with synthetic division. So we're going to go with easy one. So let's divide it by 1 and see if it works. So 1 for negative 12. Oh, oops, thank you. And negative 12 and negative 9. Bring down 1, 1, 5, 5, 5, 5. Negative 7. No, doesn't work. What do you want to try now? Wait a minute. Oh, yeah, just kidding. The 9. Why don't we try negative 1? We're going to find other, in the next few videos of this same lesson, we're going to find other ways to limit our pool. We could actually limit this a little bit further. So 1, negative 1, 3, negative 3, negative 3, positive 3, negative 9, positive 9. Look, we found one. Yay. So 1 is a factor. So now, currently, we have this. Now, this is where we get to reduce what we're dividing by, because now we have found a depreciated equation. Okay? So right now, what we have is g of x equals x minus 1, no, lies, x plus 1, okay? Because this is a factor, or this is a 0, I mean, and so when we put it back into the factored form, it would flip the sign back, right? We've got to put it back, which is, we've got to keep track of when we switch the signs and when we don't. Pretty much, you switch the signs when we're doing this unless you're doing synthetic substitution, which is where you just shove it in and go, and then you have the remainder is the answer. That's the only time we don't flip it that I can think of off the top of my head. Other than that, we flip it. Okay, so now, oh yeah, times x cubed plus 3x squared minus 3x minus 9. All right? So now, to find if there are any other zeros, we can divide by this one instead. So we can use these instead of these, which is only so helpful because this has the same number of things because that one's a 0. But, you know, every little thing. So what do we want to try now? How about negative 3? Let's do it. And we're going to divide that into 1, 3, negative 3, negative 9. Bring down the 1. Negative 3 times 1 is negative 3. 3 minus 3 is 0. Times that is 0. Negative 3, positive 9. Look, we found one through the power of magic and also math. Right? So now we have g of x equals x plus 1 times x plus 3 times x squared minus 3.
Isn't the x plus 1, is that going to be an x minus 1? Or is it because we switched?
Because this is a 0, so when we put it back into the factored form, it's going to switch back. That's right. That's right. Look, it's going to be, no. So all that this particular problem wants to know is what, if any, of these are rational zeros. This one is going to give us 2 more zeros, which is what we expect. We expect there to be 4 zeros. There are definitely 4 zeros. There are for sure going to be this many zeros. Some of them might be complex, which is the next to last video in the series. But there's definitely 4. This one has 2 rational ones, which we just found. So the answers to this problem would be, this is the potential ones, and -1 and -3 are rational ones. This one's going to come out to be 2 zeros. They're going to be irrational because it's going to be plus or minus the square root of 3, right? if you were actually to finish out and find all the zeros of this one. And I think that's pretty much all we have time for today. What we just covered is, now there are some you may want to watch the the second example from the first video, because it does one where the leading one isn't 1. So you may want to watch that, and then the other. Do what? It's the same thing. It's just going to have fractions in this list. So I will put all 4 videos on your notes assignment, and you can watch as much of the first one as you feel like you need to. If you want to count just this as your notes, you can.
Do we need to watch all 4 videos for the notes for Thursday?
Yes, ma'am. It's all one lesson. They're already made, so if you want to start today, you can.